Okay, hello, what is up, guys? Welcome back to our last lesson of February. Alright, this will be the last lesson before you go for your SPM. Okay, so what are we doing today? Today we are just doing a small chapter revision, which is our chapter 4. Alright, so a very easy chapter. Okay, so I know there's a graph to draw in this chapter. But from what I predict, this year they won't ask about the graph because it's just not, I don't know, it's too difficult for your standard, okay, even for chemistry standard. So chances are not high that they are coming out, regarding this thing. Okay, anyhow, let's go into our page 1 of our chapter 4 notes, okay, our February notes, which is our rate of reaction. All right, so you know what a rate of reaction is like, okay? We know every chemical reaction, they happen at a different speed. Some chemical reactions, they are very fast. Some, they are very slow. They take a very long time. So by the way, what is chemical reaction? Chemical reaction is when you change reactant into product. Okay, when you put 2 or 3 things together, the reactants together, and you change them into something new, okay, a completely different stuff, that's your product. Okay, so that's a chemical reaction. And of course, reactant will decrease as reaction happen, and product will increase as reaction happen. Okay, and they don't decrease in a straight line or increase in a straight line. They do so in a very fast rate at the beginning, and then they slow down as time goes on. Okay, so the graph kind of looks like they will flatten over time. Okay, they will flatten over time. Why is the graph flattening over time? Because as time goes on, reaction will slow down. Okay, I'm sure you learned this last year already reaction will slow down as time goes on. Okay, that means whatever reaction, it is the fastest in the beginning. Okay, it will slow down as time goes on, and then it will come to a flat stop as the reaction is done. Okay, so rate of reaction, it depends on one thing, which is your gradient. Okay, your keturunan. So the steeper the gradient, okay, the higher the gradient, the steeper the graph, the faster the rate of reaction. As you can see, the graph at the beginning, very steep, gradient very high. So at the beginning, when the gradient is high, that means the rate of reaction is very fast. And then as time slows down, as time goes on, the reaction slows down. Okay, can you see the graph starts to flatten, the graph starts to flatten, the gradient starts to flatten. That means the graph is slowing down. Okay, the reaction is slowing down. All right, so of course our reaction, okay, has fast and slow reaction. As I said, it depends all on your gradient. So this red color line, as you can see, this graph is flatter. Okay, it has lower gradient. And this blue color graph, it is steeper, it has higher gradient. So as you see, you also know the blue color one has faster reaction because it's higher gradient. And the red one is slower because it's lower gradient. All right, so you know what a fast reaction and a slow reaction is lah. Okay, fast reaction, they are high, okay, high rate, kadar tinggi. Slow one is low rate, okay, because they're very slow. Okay, fast one takes a short time, slow one takes a longer time. All right, example should be pretty easy. All fast reaction, they happen in a very short time, like combustion, burning something, precipitation, frying egg, neutralization, okay, acid base, and your soap and detergent. Slow one, okay, it takes a very long time. It takes minutes or even sometimes weeks or months. Okay, rusting, digestion, photosynthesis, okay, they are really, really slow. All right, so how do you know a reaction has happened? Okay, these are the telltale sign that a reaction is happening. Very easy lah, as long as your reactant is decreasing. Okay, I don't care whether it's the mass or the volume or the concentration or the product is increasing, mass, volume, or concentration. Okay, you know a reaction is happening. Okay, or the increase in or the change in pressure, temperature, pH, electrical conductivity, basically any change. A reaction is very easy to see. Okay, you know something is up. Okay, maybe there's bubble, there's color change, there's pop and bangs, okay, the sound, a chemical reaction is happening lah. All right, so we will talk about the rate of reaction now, okay, because this is the main point of this chapter. Okay, so there's 3 ways of finding out rate of reaction. Okay, by the way, what is rate of reaction? Rate of reaction is when you take your reactant or your product, you divide by time. Okay, it could be quantity, any quantity, it could be volume, it could be mass, it could be volume, whatever. All right, so rate of reaction, there's 3. You have the total rate of reaction, okay, for the whole reaction. You have the average rate of reaction for a given time, and you have the instantaneous rate of reaction. That means I want that particular time. Okay, because you see, a reaction rate of reaction will change over time. Okay, that means every second, if you look at this graph here, every second gradient is different, which means every second rate of reaction is different. Okay, so this is the least detailed way of finding it. This is the most detailed way of finding it. Okay, let's look at the least detailed way. Okay, the least detailed way, you just take the total amount divide by the total time. This is the shittiest way, the lousiest way of finding rate of reaction, because you know why? Okay, you see, I use 0.3 gram of magnesium. I dissolve in acid in 30 seconds. So you just take the total amount, 0.3 gram, divide by 30 seconds, you get 0.01 gram per second. Okay, is this the rate of reaction? No, because you see, this 0.01 has no meaning. It doesn't mean this whole thing will do 0.01 throughout the whole reaction, because like I said, rate of reaction is the fastest at the beginning, slowest at the end. This one, they just tell you, okay, it's just a number. It's like saying, okay, you take like 8 subjects during SPM, right? Okay, let's say in your exam, you take 8 subjects. Your average score is 70 marks. Does it mean you are equally good at every subject? No, it doesn't tell you any story. It doesn't tell you what subject you are weak in. Because if you look closely, maybe you score very well in maths. Your maths, you got, I don't know, 100. And then your Cerni, your Pendidikan Cerni, you got 40. Okay, that means you are really good at math, but you really suck at Cerni. But the average mark is not telling you anything. It's telling you 70. That means, oh, you might think that you are equally good at everything, but you are not. Similar story. This 0.01, it doesn't mean it just progress at 0.01 from the start to the end. No, it's just a number that doesn't mean anything. It's just a total rate of reaction. Okay, so this one is the lamest way of finding rate of reaction, because this number doesn't mean anything. Okay, so now average rate of reaction, this one is slightly more accurate, because now I split my graph into different sections. For example, I want the rate of reaction for the first 2 minutes. So I take the first 2 minutes, which is 120 seconds. I take 30 divided by 120, I get 0.25. Okay, does it mean the whole rate for the first 2 minutes is 0.25? No. Okay, this should be higher here. It should be lower and lower and lower and lower here. But this one is at least better than this, because I know that for the first 2 seconds, the average rate is around like this, 0.25. Okay, yes, it's not accurate. This is not even a straight line, because this thing is a curved line here. But hey, this is better than nothing. Okay, this is better than nothing. This one is like finding out what's your individual mark of every subject. Maybe your maths, like I said, your maths you got 100, Cerni you got 40, English you got 60. So you find out each individual mark by separating into each subject. So at least you know what subject you are good at, what subject you are weak in, better than this where you just get the total number, because it doesn't mean anything, right? So the first 2 minutes, okay, 30 divided by 120, okay, the amount divided by the time. And of course, third minute is not total 3 minutes. It means from the ending of the second minute to the end of third minute. So that means 120 second to 180 second. So this one you need to minus already. That means from here to here is 30 minus the 35 minus 30, divide by 180 over 120. So you should get your answer as 5 divided by 60, you get 0.08. That means 0.08 is here. Okay, 0.08 is here. 0.25 is here. Okay, you are splitting your graph into sections so that you find the average for each section. Yes, this is not very accurate, but it's better than this because at least now you're splitting your graph into parts. Right? Of course, the more part you split into, the more accurate it is. Like, okay, but nothing beats this. This is the most accurate. The instantaneous rate of reaction, this is the most accurate. This is like, okay, just now I said, this is like average mark in your exam, right? Okay, you get 70 marks for averagely you got 70 marks. Your average mark is 70. This one is by finding out each subject, how many marks you got. This one is like looking at each subject, at each section. Your mathematics, section A and section B, which one you score better? Which chapter are you losing marks? Which chapter are you getting all the correct answers? So in detail, I analyze your paper, see which one you're good at, which one you're weak at. This is the instantaneous rate of reaction. Very, very accurate. Also very, very troublesome to find because every second you have different rate of reaction. Okay, that means the first second and the second second and the third second, fourth second, fifth second, they all have different rate of reaction. Okay, so this one, if you really want to find the rate of reaction for every second, you have to draw like a million graphs. Okay, but now they are asking for the 20th second. So you go to the number line 20. Okay, 20th second. Do you still remember how to draw this? You put your pencil at 20 here, and then you draw this line called the tangent. What is the tangent? Tangent is the line that only touches a curve at one point. So this one, you have to put your pencil here, okay, at the 20 here, and then you have to put your ruler and adjust this yourself. You should draw a line that looks equally on both sides like this. This one is up to you already. Okay, this one is up to you. This is the most scary part of this chapter because there's a lot of work involved here. You need to draw this line, okay, and you need to find the gradient of this line. How do you find this gradient? You have to draw this triangle, this huge triangle here, and then you have to go y2 minus y1, x2 minus x1. Gradient is y2 minus y1 divided by x2 minus x1. So you have to find the gradient of this thing. Okay, I think you know how to find gradient lah. You've learned this in mathematics already. But this question, it requires a lot of time and effort. Okay, because your tangent, okay, if today we were all to draw tangent, I think you know this already. Your tangent and my tangent could be very different. Okay, that means your line and my line, there is a slight difference. Everyone's line will be different. So your answer and my answer will be different. Maybe mine is 1.4, yours is maybe 1.35, another one of you might be 1.37. But don't worry, as long as you're within that range in exam, your answer should be correct. Okay. So I hope you still remember this. We have drawn this graph for plenty of times. Okay, I don't want to repeat this here because it's very time consuming. Okay, so read back at your own notes. Okay, you should have the thing there. Okay, so y2 minus y1, okay, over x2 minus x1. So you should get your 1.4. That means the rate of reaction at the 20th second is 1.4. Okay, if you move down to second number 19 second or the 21st second, you will get different value already. Every second has different rate of reaction. That's why I say this is the most troublesome, the most tedious thing to do because every second is different. I mean, if you want, you can find each second, but what's the point, isn't it? Okay, so there's 3 ways for you to find rate of reaction. The total, this is the laziest method. Okay, the average, okay, this is slightly more work because you split them into each hour, each minute, and of course the most troublesome and the most detailed one. Okay, you find that rate of reaction for that exact second. So you need to draw a tangent. All right, so you pray hard that they don't ask for this in exam because the ultimate killer is when they give you a table, they want you to plot your own graph, and then they want you to sketch your own line. This curve line, you have to do it freehand. You have to draw it yourself, and you have to find the gradient by going to, maybe they want the 20th second or the 30th second. You have to draw your tangent here. You have to find the gradient, blah, 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 and so on. Very, very tedious work. Okay, but here's the thing. Even in chemistry, very seldom they will ask for the whole thing. It's either they will give you a lot of marks, okay, which I doubt so because you're taking science, or they will just ask you to draw this thing. Also very seldom, because like I said, this thing is something new to you. This is a completely new chapter this year. So chances are very slim that they will ask this in an exam. I'm not saying it's impossible, okay? If your luck is really bad, then maybe this one will come out this year. But from what I think, from what I predict, mostly they won't. Okay, maybe they will ask this in paper one, they will draw the triangle for you. Okay, you find the gradient yourself. Maybe it will be this way because they are trying to keep the question as simple as they can this year. All right. Again, I'm not saying this is not coming out in this year's exam. I'm saying that the chance is really, really slim. Okay, so try not to focus too much time here. Okay, because it's not worth it. All right, moving on. Next, let's go to the factor. This one you put more focus. This one for sure will come out. Okay, because the factor is something factual that you can memorize, and it's very, very easy to ask an exam. Okay, anyway, so factor of rate of reaction. Hang on, guys. Okay, sorry for that. Okay, anyway, your factor that affects your rate of reaction okay, so you have 5 factors here. Okay, 5 factors here. Okay, these 5 factors is very easy. Just remember them as how do you cook your soup faster. Let's say now you're cooking soup. How do you make your soup cook faster? Number 1, you increase the concentration. Okay, the more material you put in your soup, the better they turn out. Okay, the faster you can make your soup. Right, so I'm just going to draw arrow here. Concentration increase, rate of reaction increase. Okay, so the more concentrated acid you use, the faster they react. So you do this experiment there, the one with the X. So when you add sodium thiosulfate solution and sulfuric acid, this thing will turn white color and the X will disappear. So how long does it take for the X to disappear? It depends on the rate of reaction. If your rate of reaction is very fast, this X will disappear very quickly. If the rate of reaction is very slow, of course, this X will stay there for a very long time. So concentration. Next, please change this, guys. This is a typo. This is temperature. Okay, temperature. So as temperature increase, rate of reaction increase. This one you know lah. The hotter you cook your soup, the faster they cook. Like I said, rate of reaction is about making soup. It is about making soup. So you make your temperature higher, so they cook faster lor. Next, catalyst. This one you cannot draw arrow. Catalyst is whether they're present or not. Okay, so what is a catalyst? A catalyst is something that increases the rate of reaction. For example, your enzyme. You know you have enzyme in your digestive system, right? Okay, if enzyme is present, your digestion will be very fast. Okay, in your case, it's 3 hours. You finish digestion in 3 hours. But if you don't have an enzyme, okay, I know it's not possible, but theoretically speaking, okay, if you don't have your enzyme, digestion could take as long as 9 hours. Okay, so can you see how important your enzyme is? So I'm just gonna draw. I'm just gonna draw it this way. If catalyst is present, okay, rate of reaction increase. All right, so very simple. Next, size of reactant. Oh, this is very important. So the smaller the size, the higher the rate of reaction. Okay, why? This is something to do with your surface area. Okay, as your reactant is smaller size, the surface area will increase. Right? What do I mean? Okay, if you cook one big piece of chicken, the surface area is only that chicken like that. But when you mince it, you cut it into small pieces, the total surface area is very big because now there's a lot of exposed area to the heat. So minced meat, minced meat, they cook faster than one big chunk of meat. Let's say you are cooking pork. If minced pork, your pork is like minced, it cooks really fast. But if you cook one big piece of pork, maybe you cook it for like 5 minutes, the middle is still raw, right? That's why when you do barbecue, you cut your meat into thin slices. You don't just cook one thick piece of meat because it's really hard to cook. All right, so size decrease. Okay, size decrease, rate of reaction increase because the total surface area increase. And of course, the last will be your pressure. Okay, the higher the pressure, the higher the rate of reaction. this is why we use pressure cooker to cook something, because pressure cooker, it increases the rate of reaction. Okay, so your soup cook much faster. All right, and of course, this rate of reaction, where do we use it? This is very simple stuff. Read it yourself. Okay, the burning of charcoal. We use smaller pieces of charcoal because smaller pieces means higher surface area. Okay, they burn faster. Storing food in fridge. Your fridge is cold temperature, lower temperature. Rate of reaction is slow. That's why your food spoils slower. Okay, so all this read yourself lah. Okay, the last but not least, let's go to our industrial process. These two process, you can be rest assured that they will for sure come out. This is a must score part for you. So rather than focusing on this stupid graph here, I suggest you focus on these two processes, because even in the old syllabus, these two things will come out every year. Okay, they were in the old syllabus. So new syllabus, no exception lah. Okay, for sure they will come out. So you have two processes. Number one is Haber process. Okay, Haber process. This one is used to make ammonia. And contact process Sento. This is used to make sulfuric acid. All right. So this Haber process is very simple. It's only one process where you add nitrogen and hydrogen to become ammonia. But here's the thing. Can you see this arrow here? This arrow means it is reversible. That means this thing is very unstable. Ammonia is very unstable. That means if I add hydrogen and nitrogen together, maybe 100% will turn into ammonia and 50% will reverse back, which is not a good thing, because you see, if I'm doing, this is an industry. Industry is about making as many things as you can. Try to reduce wastage as much as you can. If this is 50% going back, I'm only getting 50% ammonia. This is a stupid business. I'm losing a lot of money. So how do I make sure the forward reaction is much more than the backward reaction? Maybe 100% go to ammonia, only 10% reverse back. You see, only 10% wastage, okay, or 5% wastage. How do I ensure that? I have three criteria. Okay, I have three conditions. You need to memorize this. Temperature needs to be 450 to 550 Celsius. 200 ATM, that means 200 times the atmospheric pressure. ATM means atmospheric pressure. And you need to use iron filling, Servolt-Bercy. Okay, when you, it's like iron powder. Okay, iron powder. So you use these three, okay, the suitable temperature, pressure, and catalyst. You should get like 90 something conversion rate to ammonia. That means only 5 to 10% convert back to this. That's very little wastage. If you use these three, you will make sure this will happen. Okay, so make sure you memorize these three criteria. Very, very important. For sure will come out in exam. And of course, for contact process, this is slightly complicated because instead of one process, this is a 4-step process. Okay, but what I want you to focus is the second process, because this is our bottleneck. Can you see the reversible? The rest is no problem. The rest are like sulfur plus oxygen, 100% will convert to sulfur dioxide. Sulfur trioxide and sulfuric acid, 100% will convert to oleum because there's no reversible. And oleum plus water, 100% will convert to sulfuric acid. So these three processes, they are not the problem. The problem is this guy. Okay, sulfur dioxide plus oxygen, you get sulfur trioxide. This is a reversible process. Means this fella sukati will go back. Like just now here lah. So like I said, if 50% is converted back, I only get 50% of sulfur trioxide here. I'm losing a lot of money because when I have very little sulfur trioxide, my step 3 will decrease. And as my step 3 decrease, my step 4 will also decrease. I affect the whole chain of reaction. So this is the key reaction here. I want to make sure I get as much sulfur trioxide as possible so that my step 3 and step 4 can proceed. So again, same, you have 3 criteria here. Okay, temperature 450 to 550, okay, if you want to write it that way. Pressure is only 1 ATM. Okay, you only need 1 atmospheric pressure here. There's no need for high pressure. And of course, catalyst, you use vanadium oxide. What is this? This is a very special powder. I'm not going to talk about detail into this. You just have to memorize this, okay? It's a powder, okay, to make this reaction faster. All right, so these two reactions, the key point would be these 3 criteria. Okay, memorize them. They will either come out in objective or subjective, okay, which is a section B there. Should be no problem, okay, because like I said, this one for sure will come out. So focus here. All right, so that's for our chapter 4. Let's go into our exercise, shall we? Okay, today we will be focusing more on exercise. Okay, so let's go to our page 2. Okay, this is in front. All right, so I'm going to skip question 1, guys, because we have done this in our old notes already. Okay, a fast reaction happens quickly. Reaction is completed in a short time. Rate of reaction is high. We have done this exact question in our chapter 4 notes. Okay, go back to your normal chapter 4 notes. We learned it last year, April. Okay, during the proper lesson. Okay, the first lesson when I taught this. Okay, so we've already done this. Okay, so photosynthesis, slow reaction. Metal, carbonate, and acid. When you see acid, it's going to be fast reaction. Combustion, fast. Fermentation is slow. Okay, penapayan. When you make alcohol, it takes years or months. So it's really slow. Okay, reactive metal and water, fast. Rusting of iron, slow. Okay, pretty easy. All right, so I'm going to skip question 1. So let's go to question 2. This is the headache one. Okay, because when you see they give you this kind of table in exam, you cross your finger hard, they don't ask you to draw. Okay, in this case, they don't ask you to draw, they only ask you to calculate, which is a huge relief, because if they ask you to draw, goodness me, it's gonna waste you a lot of time. Okay, and you need to draw, you need to sketch that stupid graph. And many students have question drawing this graph because of the freehand drawing thing. Please don't use that stupid flexible ruler. That's the stupidest thing to buy. Okay, because it's never accurate, it's really hard to use. Just draw everything using freehand. Okay, anyway, so Mikhail carried out experiment and the carbon dioxide release was collected at the interval of 30 seconds. Okay, so every 30 seconds, he recorded how much gas is collected. So calculate the overall average rate of reaction. What is overall? Like I said just now, overall means the total. Okay, this is the stupidest way to calculate things. You just take the total amount divided by the total time. Okay, I don't care the rate of reaction, they change over time. I don't care. I just want the total. So you just take the total volume divided by the total time, which is 45 divided by 180. So hang on, let me get my phone. 45 divided by 180. I should get 0.25. Okay, as for the unit, look at what you are using. cm cubed divided by second. So the answer is cm cubed per second. All right, so this number, like I said, it doesn't mean anything. Does it mean this whole rate of reaction from 0 second to 180 second, all the way it goes at the same speed, 0.25 like that? No, it doesn't, because it's the fastest at the beginning and then it slows down, slows down, slows down, slows down. At the end, it comes to a flat stop. So like I said, rate of reaction changes every second. This number, it doesn't mean anything. But hey, they're asking for it, then we don't make noise. Okay, we just calculate for them. Okay, 2 marks here. Okay, so B, average rate of reaction in the first minute. So now this is the second method. I want to split it to few minutes already. So first minute is where? First minute is here. Okay, first minute is here, or I just put it here, the first minute, because 1 minute is 60 seconds. So 31 divided by 60. Okay, the first minute. So I should get 0.52. Okay, I'm rounding up to 2 decimal places. The answer is 0.151666667. Okay, but I'm just rounding it off. So as you can see, at the beginning, the rate is very high. Okay, so this 0.25, it doesn't mean anything. Okay, because it keeps changing. All right, so average rate of reaction in the second minute. Okay, please take note. Second minute, a lot of students will say, oh, sir, second minute is 120 seconds. Okay, I just take 43 divided by 120. No, your answer is wrong. Because second minute is when you take the second minus the first. Okay, because I don't want the first minute. I only want from here to here. That means I take this, I minus this, divide by this, minus this, because I don't want anything in front here. Okay, I only want the second minute. Okay, it's like this. If you drive to Ipoh in 2 hours, the distance you drive in 2 hours and the distance you drive in the second hour is very different. The distance you drove the second hour means the first hour, the ending of first hour until you reach Ipoh there, how much you travel, the second part of the journey. So very different. So this is 43 minus 31. Okay, divide by 120 minus 60. So 12 divided by 60, I should get 0.2. Okay, that means the rate here is 0.2. Okay, the rate here was 0.52 and this is 0.2 here. Now, can you see? When I split this into different parts, they give me different number already. This 0.25, it doesn't mean anything. Okay, so average rate of reaction in the first 2 minutes, this one, first 2 minutes, you can use the whole thing. You can use the whole thing because they want the whole 2 minutes. So this one you can straight away, 43 divide 120. So don't misunderstand the question. Second minute and first 2 minutes is different thing. It's like second hour and first 2 hours is different. Okay, when you're doing exam, if your exam is 2 hours, the first 2 hours is the whole thing of a paper. Second hour is the second part of a paper. Okay, if you get what I mean. So 43 divided by 120, I get 0.358. So 36 lah. Okay, cm cubed per second. All right, that means the rate of reaction from here to here is 0.36. Okay, that means the average of these two lah. If you get what I'm trying to say. Okay, so the more you split them into, the more accurate rate you will get. Okay, so this question is good lah. There's no drawing of graph here. They only want you to calculate. Okay, but you just pray hard that they don't ask an exam, ask you to draw lah. Okay, anyway, you know what? I'm not gonna show you how to draw the graph today. I'm not gonna show you the gradient today because it's very time wasting. It's just not worth it. Okay. Oh, this one is just calculation. Never mind lah. You calculate yourself lah. This one I'm not gonna discuss. If they ask you to draw the tangent, this is the headache one. Okay. Anyway, let's skip ahead lah. Because all these are just sketching and sketching and sketching. I see, determine the gradient. Okay, this is 2 marks. Even if you don't know how to draw this thing, okay, you see, sir, die lah, this I don't know how to draw, I don't know how to calculate. Okay, hey, it's only 2 marks. Okay, it's only 2 marks. So it's not worth it. Okay, it's not worth spending so much time to just get the 2 marks there. Okay, anyway, so let's skip ahead. Let's go to question 8, shall we? Okay, so the calculation, I'm only doing it once. Just now I already done it. Okay, the calculation, the rest you can do it yourself. So check the answer lah. I'll put the answer in the group, and you can check it there. Okay, after you do it, you check it there lah. So I'm not gonna waste time. Anyway, let's look at the factor. This one is much more important. So let's look at question 8. Diagram 3.1 and diagram 3.2 shows an experiment to study the rate of reaction between hydrochloric acid and zinc. Okay, so when you add metal to acid, you're going to get hydrogen gas, as you can see here. All right, so what's the difference between these two? Let's see. Okay, so this one is acid plus zinc, okay, normal. And then this one, the second one, acid, zinc, what is this? Why is there a funny looking thing here? Copper sulfate solution. You might say, sir, what is this? I've not seen this before. Okay, when you see some funny guy appear there, definitely this guy is your catalyst. Okay, because what else could it be? There's no mention of pressure here. There's no mention of concentration here. There's no mention of temperature here. There's no mention of size here. You see, the zinc, they look the same size. There's no powder and chunk. They all look the same size. They are all granulated. So you see, when you have a funny fella here, this is the catalyst, right? That means if you add this fella, it's going to make this reaction so much faster. You see the air they collect compared to the air they collect here. So definitely this guy is the catalyst. All right. Okay, it's called Permangin in BM. So A, based on 3.1 and 3.2, state the MV. So what's the MV? The presence of this guy lah. Okay, presence of this guy. kehadiran cuprum, larutan cuprum sulfat. Okay, if you're feeling fancy, you can straight away say presence of catalyst. If you're feeling fancy lah, kehadiran pemangkin. But then again, this part is section A. Like I said, section A, you don't require studying. Even if you forgot this thing is called a catalyst, if you write presence of this guy, your answer is still correct. Your answer is still correct because this is section A. No knowledge is required. Even if you don't study, if you come to my seminar, if you still remember, section A is a part that doesn't require much studying. It's mostly about answering technique, your observation, your operational definition, your MV, RV, CV, and so on. All right, so that's the presence of your catalyst. And then the RV, what's the RV? RV is the gas here, isn't it? Okay, the gas. Okay, there's two ways to measure the gas. Number one, you can either set time and measure the volume. That means, let's say I set 30 seconds. I observe how much gas is collected in 30 seconds. Or I can set a volume and I look at the time. That means maybe I set this at 45. How long does it take the gas to reach 45? Okay, how long does it take for the gas to reach 45? So up to you, whether you want to set the time or you want to set the volume, it's fine either way. Okay, you will still get your correct answer. So the responding variable, you can say, okay, I'm going to go with volume. Okay, volume of hydrogen gas. Okay, or you can say time. Okay, time to collect hydrogen gas. So both are accepted. Don't need to write both lah. Just choose one. See whether you want to set the volume of the time lor. All right, so B, what is the function of the copper sulfate? This one you need to study already. So what's the function of this thing? It functions as a catalyst. Okay, sebagai pemangkin. All right, so state one inference for the observation in 3.2. They want you to explain this. Why is this reaction faster? Why? Why are you seeing more gas? Why are you seeing the reaction faster compared to this? Because catalyst increases a reaction, a real reaction. Okay, basically inference is explain what you see. Explain why. Why do you see this thing? Why is this reaction faster? Because catalyst increases rate of reaction. Okay, pemangkin meningkatkan kadar tindak balas. You want to say presence of catalyst also can lah. Kehadiran pemangkin meningkatkan kadar tindak balas. All right, so pay more attention to this catalyst because in your industry they will ask for catalyst. Okay, like I said here, ammonia is widely used compound in industry produced in large quantity. Name the process of ammonia and the catalyst used. So the process is called Haber process, and the catalyst is called iron fouling. Okay, cerebral besi. All right, so like I said, pay more attention to your enzyme as to your catalyst. Enzyme is a catalyst. What else? Okay, I noticed a few years when they ask for catalyst, they ask for something called a catalytic converter. You know, it's a catalytic converter. Inside your car, you have a part with catalyst. I'm not sure whether I told you this before. Your car has something called an exhaust pipe, isn't it? Underneath your car, there's a pipe that pumps out all the exhaust gases. Okay, your engine will burn petrol and it produces this rubbish gas that you don't want. So you will pump that gas out of behind your car. So you see, when you burn petrol, they are going to create all these toxic gases. Okay, these toxic gases. So in the middle of your car, there's a device called catalytic converter. I'm just gonna call it CatCon lah. We just call it CatCon because catalytic converter is a mouthful. So catalytic converter. So they will convert all your poisonous exhaust gas. Okay, and then they will convert to something harmless. Okay, a harmless exhaust gas. So all the gases coming out at the end of the tailpipe is gonna be safe. Safer at least. Okay, there's not much pollution going on because like certain countries, okay, like in the Europe, they are very strict about all these exhaust law. You cannot simply just cut this section away and just let the poisonous gas flow out to the environment because you'll be fine. Okay, you'll be fine because they care about the environment a lot. So this thing here, they put catalyst inside. Okay, they put catalyst inside. In fact, the catalyst they put inside your car is platinum. You know platinum, right? Platinum is a very expensive metal. So inside your CatCon, there's actually a lot of rare and expensive metal. This is why people steal them. Do you know this? Hey, this CatCon theft has been happening since last year because of this MCO thing. Okay, because those thieves they know you're parking your car outside your house and you're not paying attention. So what they do is they will drive to next to your car, they will jack your car up, or they will just crawl underneath your car. Within 30 seconds, they just use an electric saw, they just cut this thing off and they just run away with your CatCon. Hey, this thing can easily sell 4 to 500 ringgit. One CatCon, you know, it takes them 30 seconds to cut. Okay, and if your CatCon got cut away, if you want to replace this thing, it's going to be thousands of ringgit. Very, very headache. So this is why you don't park your car in some very dodgy neighborhood. Don't park your car in some alley or some unguarded places or some dodgy LRT station. Don't park there because your CatCon is going to be chopped away. Okay, this thing is going to be a huge pain in the ass. Okay, because in the US, this CatCon theft is everywhere. It's everywhere. Okay, the next morning you wake up, you start your car, your exhaust sound very loud, like some kind of modified sports car. That means you know that your CatCon is already chopped away lah. Okay, because this thing also filters the noise. Okay, why when you start your car you don't hear those noisy exhaust sound? Because they also filters the noise. When you chop this thing away, your exhaust is going to be very loud. So this thing they will ask an exam. So please do take note there. Okay, because they put catalyst inside to change the poisonous gas into harmless gas. All right, so anyway, number 9, an experiment was conducted to study the factor that affects the rate of reaction between marble chip and dilute hydrochloric acid. So now what are they testing? They're testing for the size. As you can see, smaller size, if I crush it, okay, the rate of reaction is faster because it takes shorter time. I told you this, right? Minced meat is faster to cook than one big chunk of meat. All right, so this is why steak is very hard to cook. Okay, I don't eat steak, okay, because I don't eat beef, okay? But you know lah, if your steak, the thicker your steak is, the harder it is to cook. Okay, because the outside will be very well done, very cooked, but the inside will be very raw. So it takes skill to cook steak. You thought every chef can cook steak that well. Okay, anyway, so A, state the relationship between size of marble chip and the time taken. I'm just going to write the shortcut here. The smaller the size of marble chip, the shorter the time taken for the reaction. Semakin kecil size ketulan mama, semakin pendek masa diambil. I'm just writing shortcut here. Exam, please make sure you write the full answer. So which marble chip has a higher rate? Of course, the small one. And the variables, okay, MV is going to be this size of marble chip. CV, constant variable, is going to be your volume of hydrogen gas. Okay, because they want to collect 30 cm. You can even say mass of marble chip. All right, because if I use 5 grams here, I have to use 5 grams here. So I need to use same mass for both experiments. I cannot be one using more and one using less, then that wouldn't be accurate. Okay, the only thing I'm changing is the size. Okay, one is powder, one is large chunk. So D, why does small charcoal chip burn easily than large charcoal chip? Okay, because like I said, something to do with your surface area. Because the surface area is larger, so rate of reaction is higher. If I break my charcoal into smaller pieces, there's more exposed area. So when there's small area, it's easier for them to burn, so higher rate of reaction. Okay, so when they're asking for the size, make sure you explain your surface area. Okay, this is a way of answering. Okay, next, number 10. An experiment is carried out to investigate the effect of temperature. Okay, so now they are doing on temperature. So they put 25 cm of acid to the beaker, put 10 cm of magnesium, oh sorry, here. Then they put the magnesium here, start the stopwatch, and then repeat the experiment using 60 degree. That means one set they do it in room temperature, which is around 20 something, another they do it in 60. So name gas P. Whenever you have acid, like I said, it's always going to be hydrogen gas. Always. All right, so B, what happened when magnesium ribbon is reacted with sulfuric acid at 60? Okay, so what happened to the magnesium ribbon? Okay, it reacts faster. Lebih laju. Because 60 what? Higher temperature what? So room temperature, you see it takes 120 seconds. 60 degree takes 80 seconds, so much shorter time. So the average rate of reaction, they want you to calculate. I'm just gonna use this 25 cm lah. Let's use this 25 cm cube. So 25 divided by 120. I get 0.21 cm cube per second. And this is 25 divided by 80. Because that's the only volume they give. It's 0.31. So you see, this is faster. Higher rate than this because the time is shorter. Why am I using 25? Because I don't think they give anything else here. Okay, this 10 cm is the length of the magnesium ribbon, so not going to use the 10 cm. So this is, unless they give the volume of this hydrogen gas here, which they didn't. So I'm just going to use the 25 cm of the acid. Okay, my point being, okay, I don't care whatever number you use. Okay, the shorter time one is always going to give you the higher rate. Okay, this is what they're trying to ask. So what's the MV? MV is the temperature. CV, like I said, it's going to be the mass of your magnesium ribbon. Okay, or you can say the volume of acid. You're going to use the same reactant. Always remember your reactant doesn't change. Okay, the volume and the mass of the reactant doesn't change. I need to keep my reactant the same amount. Okay, I'm only changing either the concentration, the catalyst, the temperature, the pressure, whatever. All right, so E, rate of reaction is higher when temperature increase. Explain this statement based on the kinetic energy. Wow, sir, why is this here? Okay, this kinetic energy, you have actually learned it in your Form 1. Do you remember? When you heat something more, the particles is going to vibrate faster. Remember? When your solid vibrates faster, when it is fast enough, they will split and then they turn into liquid, or liquid will turn into gas. Okay, so something to do with that. So as you can say, when temperature increase, okay, so particles have higher kinetic energy. Okay, zara-zara mempunyai tenaga kinetik yang lebih tinggi. Okay, so how does this Ke affect your rate of reaction? You might say, okay, yes, sir, I know particles vibrate faster. How is particle moving faster increase the rate of reaction? Okay, because when you have higher Ke, particles collide with each other more frequently. Okay, berlanggar dengan lebih kerap. The more they will langgar with each other. So the more they langgar, the more reaction they have lah. Okay, I know this is not in your syllabus, but let me just tell you this. Rate of reaction is about collision, it's about colliding. When two reactants, they langgar together, only they will have chemical reaction. If there's no langgar, no collision, there will be no reaction. So the more you heat them, okay, the more you panaskan them, the more reaction, the more kinetic they have, the more they langgar, the more reaction you have lah. So real reaction works that way. Okay, so chemistry student, they learn this, but you don't. But common sense, isn't it? Okay, the more they collide, the more reaction they have. Okay, so let's look at question 11. So diagram below shows two sets of experiment to study the factor of concentration of hydrochloric acid. So as you can see, this one has lower concentration. So the rate of reaction lower lah. There's less gas. This one higher rate of reaction. Then there's more gas, higher rate of reaction. Higher concentration, higher rate of reaction. Okay, so calculate the average rate of reaction in set A. Just take your gas, 60 here. Divide by 3 minutes. That means 180 seconds. 0.33 cm cube per second. You know, use minute also can. If you are lazy to convert this to second, just use minute. Then your unit would be cm per minute. So compare the rate of reaction between set B and A. Of course, B is faster than A. Okay, because it has more gas here. So explain the effect of concentration on the rate of reaction. Okay, so how does reaction? Yes, we know when concentration increase, rate of reaction increase, but how? Same thing, something to do with your collision. Okay, wow, why are they asking for chemistry stuff? Okay, this is something to do with your collision. So when you have higher concentration, okay, you have more particles. Okay, more particles, because more crowded, what? More concentration, what? So when you have more particles, you have more collision, just like just now. Okay, more collision. So when you have more collision, you have more reaction. Okay, more reaction or higher rate of reaction. Okay, 3 marks here. Of course, in exam, don't write it this way lah. I'm just keeping the answer short. Okay, so let me repeat. Higher concentration means more people around. There's more particles hanging out inside the water, the liquid. Inside there's more people. When there's more people, there's more collision, more langgar. When there's more langgar, then more reaction. Okay, so what is meant by high concentration of reactant? That means you have high, okay, you have large amount of reactant in a liquid. Okay, jumlah reaktan yang tinggi di dalam cecair. Okay, easy peasy. Next, let's look at number 12. So cooking meat. Okay, so if you cook small pieces of meat compared to when you cook large piece, so which will take shorter time to cook? Well, of course, it's going to be A. Explain your answer because it has smaller size. Okay, smaller size cook faster. Which has higher rate of reaction? A again. What is the relationship between size and rate of reaction? Okay, the smaller the size, the higher the rate of reaction. So small pieces of meat are then cooked at different fire intensity. Oh, so now they split this into two. They cook at different fire. Different fire means different temperature lah. Stronger flame means higher temperature lah. So the first small pieces of meat are cooked over low flame. One side they use small flame, that means low temperature. Second, small pieces of meat are cooked over high flame. This one they use high temperature, they use hot flame. In your opinion, which will cook first? Well, of course, the high flame lah. Well, this is a very straightforward answer. Okay, anyway, mark other factors that affect the rate of reaction. Okay, it's going to be your concentration and pressure. Okay, mass and color doesn't affect. Nothing to do with that. Okay, you know what? I think I'm gonna stop here. The remaining one, you can actually go and do it yourself. Okay, I'll leave some of you to do because if I finish this, then there's no more exercise for you to practice. Okay, so go home and do this. This is the ammonia one. Like I said, focus on the ammonia, the harbor, and the contact process. They are quite important. All right, so the answer, I'll put this in the Google Classroom. Okay, make sure you check your answer there. All right, so I wish you all the best for SPM. Okay, you're having your first paper next week, isn't it? Okay, make sure you don't panic. Make sure you get enough sleep. Okay, the first paper, like I said, you will feel the most panic one. All right, so I will see you again soon. Okay, before our science paper, I think I will still see each other for a few times. Okay, so wish you the best of luck. I will see you again when I see you again. All right, so have a happy Friday, guys. Okay, see you. Take care and good night. Bye-bye.